got to sneeze. There you go. Goodness. Usually I do 3, and that was just 1. Okay, and I've also got to figure out what exactly I've done to the printer. You know how that worksheet printed, like the back side was upside down? I'm not exactly sure, but I printed out a bunch of stuff this morning, and it printed the same way. And I'm not sure what the setting is that's making that happen. So I have to figure that out. Anyhow, let's get going. Okay, so moving on to section 3.2. The 3.2 notes are split up into 2 days. So there's a 3.2a and a 3.2b. So we learned last time that parallel lines are coplanar lines that do not intersect. And a transversal is a line that intersects 2 or more coplanar lines in different points. So we got our definitions down. Hang on, I gotta blow my nose now. I'm sure that's a pleasant sound on a video. Okay, so postulate. Now remember, postulates, we do not have to prove postulates. These are, oops, what's that? God. Okay, oh my goodness, what have I done? Go away. Okay, so these, remember, are accepted without proof. So here's our postulate that all the theorems are going to be based on. If 2 parallel lines are cut by a transversal, so right now we've got 2 lines, K and L, cut by a transversal T. Now, remember, if you don't tell people they're parallel, then they're not. So remember, we can add that extra set of arrows like we did last year. So now we have 2 parallel lines, K and L, cut by a transversal. Then corresponding angles are congruent. You already know this. So angle 6 corresponds with angle 8, because top right corner of where the 2 lines are getting crossed by the transversal. If the lines are parallel, those are congruent. So now we also know that angle 1 is congruent to angle 6, because vertical angles are congruent, which makes all these the same size. And then 2 and 6 form a linear pair. 2 is vertical to 5, but 2 is congruent to 4, because those are corresponding angles. 5 is congruent to 7. Those are corresponding angles. So just the fact, it just makes sense. Again, we learned it in 8th grade math, so it can't be that difficult. We know that angle 6 is congruent to angle 8, so 6 and 8, top right corners. We know that angle 5 is congruent to angle 7, so bottom right corners, we know those are corresponding angles. We know 2 is congruent to 4, top lefts, and we know that angle 1 is congruent to angle 3. All right, now all the other theorems are based on that one postulate. So here's our first theorem that you've got to, this is another one, it's like, this is, you're going to write this word for word when it shows up in a proof. So if 2 parallel lines are cut by a transversal, so here's our given, that the lines are parallel, so we'll add that to our picture. Then alternate interior angles are congruent. So what we're going to prove, we're going to pick one pair of alternate interiors. Our job is to prove that angle 1 is congruent to angle 8. So we start with our given, K is parallel to L. And we need something about either angle 1 or angle 8. Okay, so let's say we do, oh, what's it doing? It's acting weird. Hang on. I picked the pen, right. There it goes. Let's say that angle 1 is congruent to angle 3. Because parallel lines cut by a transversal implies congruent corresponding angles. So I could write out that entire postulate up here. If 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. But that's about as quick as you can say it and still say it. So we can use that arrow that points this like this implies this. And I moved it down here just because like I was running out of room, but in my mind it doesn't really make any sense if I don't put the arrow next to the thing that's leading to the other thing. So I'm gonna move it back to there. So then we've got angle 1 congruent to 3. Now we know that angle 3 is congruent to angle 8 because vertical angles are congruent. Vertical angles are congruent. And then we can say then that angle 1 is congruent to angle 1 is congruent to angle 8 because of the transitive property of congruence. Now remember, there is no such thing as a substitution property if we're talking about congruency. So you only substitute numbers. So it has to be a value using an equal sign. If you're going to ever say substitution, don't ever say substitution if it's a congruency, if it's an actual geometric shape. Now, we don't have to ever go through that again because now we have our theorem that we can use as a reason. It's like we can jump to the fact that you know that when those lines are parallel, that alternate interior angles are congruent. Okay? All right, so next up, next theorem, if two parallel lines are cut by a transversal, so they're telling us K is parallel to L, then alternate exterior angles are congruent. So they just picked a set. They picked 3 and 6. Those are alternate exteriors based off the vocabulary we learned in section 3.1 and in the 8th grade. So we've got to have something with angles 3 and 6. And there's lots of ways we could go about it. I usually stick with my corresponding angles. So like I'd probably say maybe that angle 6 is congruent to angle 8. Because technically you don't have to know any of these theorems. You just have to know that postulate. Like the other theorems that you've learned before will get you to all these. But it's much quicker, again, the more theorems you know, then the quicker you can get to your conclusions. So angle 6 congruent to angle 8 because parallel lines cut by transversal implies congruent corresponding. I should probably just abbreviate corresponding, but I'm not gonna. Okay, so now we've got that 6 is congruent to 8. Well, 8's congruent to 3. Because vertical angles are congruent. Which leads us to angle 3 is congruent to angle 6 because of the transitive property. Okay, so again, there's the one you want to know. We just proved it. You never have to prove it again if you don't want to. But if two parallel lines are cut by transversal, then alternate exterior angles are congruent. Okay, next up, if two parallel lines, so given is that the lines are parallel, are cut by transversal, then same side interior angles are supplementary. So they picked 2, they picked 1 and 4 that are same side interiors. So let's just see what we can do with that. We got to use one of those two. Like we got to start with either something about angle 1 and angle 4. So why don't we start with 1 and 3 are congruent. So angle 1 is definitely congruent to angle 3 because parallel lines cut by transversal leads us to know that we have congruent corresponding angles. I think we've done that enough times in a row that we can just shortcut. Now, in a test, don't ever shortcut. Like shorthand corresponded, actually spell it out. But I think we're okay to do that right now. It's just me and you, Ethan. We're fine. All right, so what else do we want to do that? So we got to throw angle 4 in here. So, let's do that these measures are the same by the definition of congruent angles. And that way we can start talking about, we know that the measure of angle 3 plus the measure of angle 4 is 180 degrees because that makes a linear pair postulate. Well, I said that weird. Doesn't make a linear pair postulate. Those two angles form a linear pair, and therefore the linear pair postulate holds up. So the linear pair postulate tells us we can do that. So where the measure of angle 3 is, I can replace it with the measure of angle 1. And that's a substitution because I'm substituting numbers. The measure of an angle, that's a number. Okay? And then if I said that there are two measures add up to 180 degrees, well, that's the definition of being supplementary. So I would jump straight to what I was trying to prove, that angle 1 is supplementary to angle 4 because of the definition of supplementary angles. Okay. Oh, so again, theorem. Oh, that's not what was supposed to happen. Highlighter, Gwen. If two parallel lines are cut by transversal, then the same side interior angles are supplementary. Okay. Next theorem. Again, remember, we have to prove a theorem before we can actually use it. So even though I know you already know these things, we are officially proving them, and then we will use them to our heart's content. But you can't use a theorem unless you've actually proven it. Which, I guess technically in the 8th grade, we did not adhere to that because we used the Pythagorean theorem all the time and we never actually proved it. We just noticed that it worked, which is not a proof. It's not the same thing. But at the same time, y'all didn't know the math needed to actually prove it. So this year we will prove the Pythagorean theorem, and I think you'll enjoy that. And I think we'll get to it before Christmas. I'm pretty sure all the right triangle stuff comes out before Christmas. Anyway, so next one. If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other one. Okay, so if a transversal, so they're shown in the diagram, T is my transversal, it's perpendicular to one of two parallel lines. So they've got to be telling me that T's perpendicular to one of them, and they picked L, okay, and that L is parallel to N. So that's all given from the hypothesis. So those are my givens. What we're trying to prove is that, so that line T, the transversal, we're trying to prove that it's perpendicular to N as well. Okay, so let's just start with this. What should we start with? Well, we've got the perpendicular lines. Let's use the definition of perpendicular lines. I know that angle 1 is a right angle. And I already drew that in the picture. Like, I think the drawing on the pictures help more than anything, because if I draw it, then I have to write it. So I drew in a right angle, and the reason I knew that is because that's the definition of perpendicular lines. Perpendicular lines are lines that intersect at a right angle, okay? So if that's a right angle, then we know its measure is 90 degrees, because that's the definition of a right angle. Let's see what we want. I know, we got to keep talking about angle 1 because that's the only one we've thrown in so far. We know that angle 1, oops, come back. Why does the screen act like that? It's weird. So angle 1 we know is congruent to angle 5 because when parallel lines, so I know 1's congruent to 5. Parallel lines cut by transversal implies congruent corresponding angles. All right, that means that the measure of angle 1 equals the measure of angle 5. Oh, I'm going to run out of room. Because that's the definition of congruent angles. So then I could come back, and since I know the measure of angle 1 is 90 degrees, I could put that 90 degrees is equal to the measure of angle 5, because that's a substitution. I substituted a number. Okay. So then that makes, I really am going to run out of room. That makes angle 5 a right angle, because that's the definition of being a right angle. And if angle 5 is a right angle, then that means T is perpendicular to N. 6, 7, okay, 8. T is perpendicular to N because that's the definition of perpendicular lines. is the fact that when they intersect, they form a right angle. I should put more room in those notes. Okay, so next part, here's the part that you'll enjoy. I don't know. I think you kind of enjoy the proofs just as much as the math. So we've got our two parallel lines this way. Let's treat this as the transversal. So we're sitting here looking at x and 2y. So those are corresponding angles. So I know that x is equal to 2y. So there's one thing I know. Okay. If I look at these two the two yellow parallel lines with that purple transversal, then this, actually I could mark them all the same because by the transitive property, these are all the same. So I know this is 110 degrees. So if 110 equals 2y, then y has to be 55. And do they have the degree signs on there? Yeah, I drew them in. So we can just say that x is 110 and that y is 55. And now that I've started working on these, Ethan, you're probably just going to turn the video off for a second and try these on your own and then come back and see how you did. So we got our two parallel lines. Here comes a transversal. This angle and this angle are corresponding angles. That means they are congruent. So x has to be 60. And then over here, let's see what color. Let's do pink for this transversal. These are same side interiors, which are supplementary. So we know that y plus 50 has to be 180, so y's got to be 130. So x is 60, y is 130. Okay, right here we've got our two parallel lines. Here comes along a transversal. Ooh, I lost my blue highlight. Ooh, I like that blue. Let's do that. Okay, anyway, let's see. These are corresponding angles from those parallel lines. So if this is 80 degrees, this is 80 degrees. So 2y is 80. Y's got to be 40. And if that's 80 degrees, this is a linear pair. So this is 100 and, oh my gosh, total is 180 degrees. So this is 100 degrees, which is what x is. So y is 40, x is 100. Let's see what we got on this one. So here's our two parallel lines. Here's our transversal. If that transversal is perpendicular to one of them, then it's perpendicular to the other. So this has to be a 90-degree angle. If that's 90 degrees, this has to be 90 degrees. So 3y has to equal 90. So y's got to be 30. So x is 90. Y is 30. Okay. What else we got? Oh, another theorem. Yay, yay. Is this it? Yep. Okay. So if two parallel lines are cut by a transversal, okay, so here's our parallel lines. We got our given down here. Two parallel lines cut by a transversal. Then angle two, what we're trying to prove. Same side exterior angles are supplementary because we never did prove that one. So we're going to actually physically prove it. So they're picking 2 and 3. I'm going to say, okay, let's prove that those are supplementary. So let's just start out talking about 2 then. So we know angle 2 is congruent to angle 4. Because parallel lines. Can you tell you're going to write this a lot? Cut by a transversal implies congruent corresponding angles. All right. If that's the case, then their measures are the same. Because that's the definition of congruent angles. All right, so we got to get angle 3 in the mix. So we can come down here and look at where 4 and 3 are. So we know that the measure of angle 3 plus the measure of angle 4, we know that's 180 degrees from the linear pair postulate. And then we can plug in where the measure of angle 4 is. We can put in the measure of angle 2. With a substitution. And then we can say what they want us to say. 2, and we're going to say it exactly in that order. So angle 2 is supplementary to angle 3 by the definition of supplementary angles. And I know I get really messy with these notes, Ethan. I don't really worry about it much because I'm saying it, and I know that you know what I'm saying. I know that you know how to spell all these things. So if I were doing this for real in class, I would probably not be quite so messy, but I do this every morning when I get to school. So yeah, a little messy. I don't think it's going to hurt anybody. So what we're going to do today is I want you to go back and do I don't know if you finished that worksheet from Friday. If you didn't finish the worksheet and check your answers, do all that first, okay? Then do the book work from Friday. And then there's 2 bits of homework that go with today's. And let's do it kind of like we did last week. Let's do the worksheet today, and then on Tuesday, tomorrow, we'll come back and pick up that book work. And then after you do that book work, then we'll do the next set of notes. I think that'll work out fine.